Look at the ground beneath your feet. Right now, it feels solid, doesn't it? It feels permanent. You trust it. You build your homes on it. You drive across it. You assume that the layout of the world, the shapes of the continents, the vast distances of the oceans is a fixed constant in a chaotic universe. We are taught that the stars move, that the galaxy spins, but that the Earth is our anchor. This is the single greatest illusion of human existence. The ground you are standing on is not a floor, it is a raft, and that raft is drifting on a sea of pressurized molten rock that has been churning since the birth of the solar system. You're not standing on terra firma, you're standing on the skin of a beast that is slowly, agonizingly stretching in its sleep. If you could speed up time, if you could compress the next 250 million years into a single hour, you would see the terrifying truth. The Earth is not finished. It is currently in the middle of a violent, crushing cycle that cares absolutely nothing for the biology clinging to its surface. We are living in a brief, lucky interlude, a geological pause. But the pause is ending. The engines deep inside the planet are gearing up for the next great act of destruction. The continents are moving, they are turning around, and they are coming together to crush the life out of this world. Scientists call it the Supercontinent Cycle. It sounds academic, almost rhythmic. But the reality is a slow-motion car crash on a planetary scale. We are heading toward a new configuration, a new world map that would look utterly alien to you. A world where the Atlantic Ocean is gone. A world where the Americas have crashed into Africa and Europe. A world where the sky burns and the oceans turn stagnant. They call this theoretical landmass Pangea Ultima, the final Pangea. And its formation will likely mark the end of the mammalian age. To understand why this is happening and why it is inevitable, we have to strip away the atmosphere and look at the machine itself. Picture the Earth not as a blue marble, but as a heat engine, a furnace. The core of our planet is as hot as the surface of the sun, trapped under thousands of miles of crushing rock. That heat wants out. It is desperate to escape. It pushes upward, driving the mantle, that thick plastic layer of rock, into massive rolling convection currents. Imagine a pot of thick soup boiling on a stove. You see the skin on top? It cracks, it slides, it gets sucked down in some places and pushed up in others. That skin is us. That skin is every city, every mountain, every ocean floor you have ever known. For the last 200 million years, we have been in a phase of dispersal. The continents have been breaking apart, drifting away from each other, creating the Atlantic, widening the gap between the old world and the new. This dispersal has been good for life. It creates coastlines. It regulates the climate. It allows ocean currents to circulate freely, keeping the planet cool and oxygenated. But the pendulum is swinging back. The dispersal is over. The gathering has begun. The mechanism of our destruction is already active. It is happening in the silence of the deep ocean, where no sunlight ever touches. To understand the future, you have to look at the scars of the past. We have been here before. This is not the first time Earth has tried to kill us with a supercontinent. 300 million years ago, there was Pangea. Just Pangea. It is famous in textbooks as a cute puzzle where South America fits into Africa. But in reality, Pangea was a biological nightmare. When all the land masses smashed together, they created a trap. The interior of the continent was so far from the ocean that rain clouds couldn't reach it. It became a super desert, a furnace of extreme temperatures. The coastlines, the places where life thrives, were drastically reduced. And then came the Great Dying, the Permian-Triassic extinction event. It wasn't an asteroid that killed 90% of all life on Earth back then. It was the planet itself. The configuration of Pangea choked the oceans, it stopped the currents. The water became stagnant, devoid of oxygen, turning into a toxic soup of purple sulfur bacteria. The atmosphere filled with carbon dioxide. Life suffocated. We are marching toward a repeat of that history. But this time, the stakes are higher. This time, the sun is older. It is brighter. The heat that Pangea Ultima will trap will be unlike anything the Earth has seen in 1 billion years. We're not just looking at a rearrangement of the map. We are looking at the construction of a planetary oven. Let's trace the sequence of events. It begins with a paradox. Right now, the Atlantic Ocean is growing. Every year, Europe and America move about an inch further apart. Lava bubbles up in the centre of the Atlantic, pushing the plates away. It seems like we are drifting into isolation. But this is a temporary anomaly. The real action, the violence, is happening in the Pacific. The Pacific Ocean is dying. It is the largest feature on Earth, a vast blue expanse that covers almost a hemisphere. And it is being eaten alive. All around the rim of the Pacific, the Ring of Fire, the ocean floor is being forced under the continents. It's a process called subduction. The heavy, cold rock of the ocean floor dives beneath the lighter rock of the land, vanishing into the burning mantle below. This is why Japan has earthquakes. This is why the Andes Mountains are rising. The Pacific Plate is being consumed. As the Pacific shrinks, the continents on either side are being pulled toward the void. North America is drifting west. Eurasia is drifting east. Australia is rocketing north, destined to smash into Asia. The closing of the Pacific is the first domino, but there is a twist, a geological betrayal that will seal the fate of the Atlantic. Computer models, running simulations of deep time, have revealed a terrifying scenario. The Atlantic Ocean, currently widening, will eventually run out of momentum. The mid-ocean ridge, that zipper running down the centre of the ocean floor, will fail. The rock will grow old, cold, and heavy. And gravity, the most patient force in the universe, will take over. Picture the coast of the eastern United States, New York, Florida, the Carolina beaches. Right now, these are passive margins. The land gently slopes into the sea. There are no volcanoes, no great earthquakes. It is geologically quiet. But silence never lasts. Eventually, the oceanic crust of the Atlantic will become so dense that it will break. It will snap away from the continent. A massive tear will open up along the entire east coast of North America and potentially along the coast of Europe and Africa. This is the moment of subduction initiation. The moment the Atlantic turns from a growing ocean into a dying one. Once this happens, the process accelerates. The Atlantic floor will begin to slide beneath the Americas. The ocean will begin to close. The vast distance between New York and London will shrink mile by mile, year by year. It won't happen in a human lifetime, but to the Earth, it will be the blink of an eye. The continents are like magnets flipped to attract. Imagine standing on a beach in a future version of North Carolina. The horizon is no longer flat. It is jagged. Volcanoes are erupting from the seafloor, breaking the surface, creating a chain of islands that spew ash and lava. The water is receding, not from a tide, but because the ocean basin itself is being squeezed shut. The sky is dark with particulate matter. The sun is a hazy, angry red ball. You're witnessing the beginning of the Great Collision. But it isn't just the Americas and Europe. The southern hemisphere is joining the brawl. Africa, already pushing hard into Europe, creating the Alps, will continue its northward crusade. The Mediterranean Sea, that cradle of civilization, that beautiful blue jewel, is doomed. It is being squeezed out of existence. Africa will smash into Europe, obliterating the Mediterranean entirely. The Alps will shoot upward, becoming as tall as the Himalayas. Italy will be crushed into the bulk of the new supercontinent. The history of Rome, of Athens, of Cairo, will be ground into dust and lifted 5 miles into the thin, freezing air. And then there is Australia, the rogue continent. It is moving fast, relatively speaking. It is hurtling north, destined to collide with the islands of Indonesia, and then slam into the soft underbelly of Asia. This collision will act as the welding point, fusing the southern landmasses to the north. Antarctica, currently frozen and isolated at the bottom of the world, will eventually be dragged north by the shifting currents of the mantle. It will shed its ice as it enters warmer latitudes, revealing a scarred, barren landscape that hasn't seen the sun in 30 million years. It too will join the assembly. So, here is the picture taking shape. 250 million years from now, the Atlantic is gone, the Pacific is gone or unrecognizable, the Indian Ocean is a trapped inland sea, all the world's major landmasses have collided into a single massive lump. Pangea Ultima. It will look like a fortress. a singular, massive island floating in a global ocean called the Panthalassic. From space, the Earth will look lopsided. One side, a vast, unbroken blue, masking the horrors of the deep. The other side, a brown, red and grey scab of rock. But the formation of the land is just the architecture. The true horror lies in the climate this structure creates. You have to understand that continents are not just dirt, they are climate modifiers. They control the flow of heat and moisture. When you scatter them, as they are now, you allow wet ocean air to penetrate inland. You get rain, you get rivers, you get forests. When you fuse them together, you destroy that cycle. The interior of Pangea Ultima will be thousands of miles from the nearest coastline. Rain clouds forming over the global ocean will travel inland. They will dump their water on the coastal mountain ranges, the massive peaks formed by the collision of the Americas and Africa. By the time the air reaches the centre of the continent, it will be bone dry. We are talking about a desert the size of North America and Eurasia combined. A hyper-arid wasteland where rain might not fall for decades. But it's not just dry, it is hot. Here is the variable that makes Pangea Ultima different from the Pangea of the dinosaurs: the sun. Stars evolve. Our sun is a main sequence star, and as it burns through its hydrogen fuel, it gets hotter and brighter. It increases its luminosity by about 1% every 100 million years. That doesn't sound like much, but over 250 million years that extra energy adds up. The sun beating down on Pangea Ultima will be 2.5% brighter than the sun you see today. Combine that increased solar radiation with the geography of a supercontinent. The interior rock, far from the cooling influence of the ocean, will absorb that heat and hold it. Continental climates are naturally more extreme. Hotter summers, colder winters. But on a supercontinent, this effect is amplified to a lethal degree. We are predicting summer temperatures in the interior of Pangea Ultima to regularly exceed 40 to 50 degrees Celsius. That is 104 to 122 degrees Fahrenheit, not as a heat wave, as an average. During the peak of the day, in the lowlands of this central desert, temperatures could spike to 60 or 70 degrees Celsius. Proteins break down at those temperatures. Water evaporates instantly. Complex life, mammals, birds, anything that relies on regulating its own body temperature, cannot survive there. The centre of the world will be a dead zone, a vast, sterile expanse of red dust and jagged rock, howling with winds generated by the extreme temperature, differences between the scorching land and the cooler ocean. But wait, it gets worse. Because the continents have smashed together, the volcanic activity will be off the charts. The collision zones, where the plates are grinding against each other, will be active. But the real threat comes from the carbon cycle. Normally, rain washes carbon dioxide out of the atmosphere. It binds with rocks, weathering them, and eventually ends up on the ocean floor. It's the planet's natural thermostat. But in the interior of Pangea Ultima, there is no rain. The weathering stops, the thermostat breaks. Meanwhile, volcanoes continue to pump CO2 into the air. The levels of greenhouse gases will skyrocket. We could see CO2 levels rising to double, triple, maybe 10 times what they are today. This triggers a runaway greenhouse effect. The atmosphere thickens, the heat is trapped, the planet begins to fever. And this brings us to the most terrifying realization of all: the anomaly. We usually assume that life is resilient, that life finds a way. We look at the history of Earth and see a story of triumph. But the formation of Pangea Ultima reveals a darker truth. The Earth is not benevolent, it is indifferent, and it has a reset button that it presses periodically. The anomaly is this: the conditions for Pangea Ultima align almost perfectly with the conditions for a moist greenhouse catastrophe. This is a state where the stratosphere becomes wet, and water vapour, a potent greenhouse gas, accelerates the heating until the oceans themselves begin to evaporate. We are not just looking at a desert, we are looking at the possibility of the Earth becoming a second Venus. The models show that mammals, the group of animals that includes us, are particularly ill-suited for this future. We are efficient, warm-blooded creatures. We generate our own heat. That is our superpower in a cool world. But in a world where the ambient temperature is higher than our body temperature, our superpower becomes a curse. We cannot cool down, we cook from the inside out. The habitable zones of Pangea Ultima will be restricted to the extreme fringes. the very edges of the northern and southern coastlines, maybe a few high-altitude plateaus. The rest of the planet, 90% of the surface area, will be a kill zone. Humanity, if it still exists in some recognizable form, will be forced into these refugees, huddled on the edge of a boiling sea, looking back at a continent that has become a tomb. But the collision hasn't happened yet. We're still in the early stages. The pieces are just starting to move into position. The trap is being set. And the first sign that the trap is snapping shut isn't in the rocks, it's in the water. Deep in the Atlantic, sensors have picked up something strange. A silence where there should be noise. A slowing of the currents that drive the world's weather. The great conveyor belt, the circulation system of the oceans, is stuttering. Is this the beginning? Is the engine shifting gears? To understand exactly how this transition will tear the world apart, we have to go deeper. We have to look at the physics of the collision itself. We have to understand what happens when an unstoppable force meets an immovable object, and why the result isn't just an earthquake, but a rewriting of the laws of survival. We need to talk about the mechanics of a murder. Not a crime of passion, but a cold, calculated geological execution that has been in the planning stages for millions of years. To understand the fate that awaits us on Pangea Ultima, we cannot just look at a map. A map is static. A map is safe. We need to look at the engine room. We need to understand the sheer, terrifying power of the forces dragging these continents together, and why the resulting collision is not merely a rearrangement of scenery, but a fundamental breaking of the world's life support systems. When we say continents collide, it is easy to visualize two bumper cars tapping together in slow motion. This analogy is dangerously wrong. It minimizes the violence. The continental plates are not floating passively, they are being driven. They are the cooled capstones of massive convection cells, churning pillars of hot rock thousands of miles deep. The energy pushing North America westward is incomprehensible. It is more energy than every nuclear weapon humanity has ever built, firing continuously for 100 million years. When these unstoppable forces meet an immovable object, another continent, the result is a geological trauma that scars the planet forever. Think of a hydraulic press crushing a block of concrete. The concrete doesn't just neatly fold, it fractures, it crumbles, it screams as the internal structure fails. That is what will happen to the Earth's crust. As the Atlantic closes and the Americas slam into Africa and Europe, the crust will buckle. It has nowhere else to go but up. We have seen this before. The Himalayas, the highest mountains on Earth today, are a recent wound caused by India smashing into Asia. They are still rising, growing by millimeters every year as India continues to push. But the mountains of Pangea Ultima will make the Himalayas look like foothills. The collision that forms the final Pangea involves nearly all the continental mass on Earth arriving at the same focal point simultaneously. The pressure will be unprecedented. Along the seam where the old Atlantic used to be, a new mountain range will rise. It will be a titanic, jagged spine running from the new North Pole to the new South Pole. Geologists model these future peaks towering perhaps 30,000, maybe 40,000 feet into the air. They will pierce the thin upper atmosphere. Their peaks will be permanently frozen, locked in ice even at the equator, while their bases are ringed by scorching deserts. They will act as a massive, insurmountable wall, blocking air currents, blocking migration, physically dividing the supercontinent into isolated climate zones. But the mountains are just the debris of the collision. The real killer is what happens to the plumbing. The Earth, as it exists today, is a water-cooled machine. The oceans are the circulatory system. The currents, the Gulf Stream, the Antarctic Circumpolar Current, they are the arteries and veins moving heat from the equator to the poles, keeping the planet temperate. They churn the water, mixing oxygen down into the depths and bringing nutrients up to the surface. When Pangea Ultima forms, this circulatory system suffers catastrophic heart failure. Imagine the new global ocean, the Panthalassic. It is vast. It is so wide that it covers more than half the globe in an unbroken stretch of water. Without the complex arrangement of continents to guide and deflect the water, the currents become sluggish. They simplify. The great mixing machine slows down. This leads to the terrifying concept of ocean stagnation. A flowing stream is healthy. A stagnant pond becomes septic. When the ocean currents stop moving with vigour, The oxygen supply to the deep water is cut off. The abyss begins to suffocate. The fish die. The whales die. Anything that needs oxygen perishes, sinking to the bottom to rot. But the ocean doesn't become sterile. Oh no. It finds a new, older way to live. In the absence of oxygen, ancient anaerobic bacteria take over. These are the life forms that ruled the Earth before photosynthesis poisoned the atmosphere with oxygen billions of years ago. They thrive in the dark, sickly silence of a stagnant ocean. As these bacteria feast on the decaying organic matter in the deep, they produce a waste product, hydrogen sulfide gas. It is highly toxic to oxygen-breathing life. It smells like rotten eggs. It turns the water a sickly, opaque pink. On Pangea Ultima, as the stagnation spreads, this pink water will rise from the depths. It will creep up the continental shelves. The beautiful blue ocean you know today will be replaced by a poisonous, fuchsia-coloured sludge licking at the shores of the supercontinent. And then the gas escapes. Massive bubbles of hydrogen sulfide will burst from the ocean surface. Toxic clouds will drift inland, silent, invisible killers. If you were standing on the coast of Pangea Ultima, looking out at that vast, pink, silent sea, the air you breathed would burn your lungs. It would be a poison gas attack orchestrated by the planet itself. This phenomenon, a Canfield Ocean, is believed to have been a primary driver of the greatest mass extinctions in Earth's history, and we are actively building the architecture for its return. So we have a supercontinent ringed by poison water. But what about the land itself? What about the interior? This is where the physics of heat entrapment creates a hellscape beyond human endurance. You must understand that land and water behave very differently when heated by the sun. Water is stubborn. It takes a lot of energy to heat it up, and once it's hot, it holds onto that heat. It moderates the climate. Land is reactive. Rock and dirt heat up fast and cool down fast. Without the moderating influence of the ocean, you get continentality, extreme swings in temperature. Today, central Siberia or the middle of the Sahara Desert give us a taste of this. But Pangea Ultima is continentality taken to its absolute lethal extreme. The interior of this supercontinent will be thousands of miles from the nearest source of moisture. The massive new mountain ranges will act as rain shadows, scraping every last drop of moisture from the air before it can reach the center. The interior will not just be a desert. It will be a hyper-arid wasteland, drier than the Atacama, larger than any desert that has existed since the dawn of complex life. And then the sun beats down. Remember, the sun is brighter now. That extra 2.5% luminosity is hammering the center of this vast landmass. The rocks absorb the heat. The ground temperature soars. There is no vegetation to shade the soil, no evaporation to cool the air. The climate models paint a picture of a world burning. Average summer temperatures in the interior could hover around 50 degrees Celsius, 122 degrees Fahrenheit. That's the average. Horrifying heat waves will push the temperature over 60, perhaps 70 degrees Celsius. At these temperatures, the physics of biology begins to fail. Proteins denature, they cook. The delicate chemical machinery that keeps a cell alive simply unravels. And this brings us to the cosmic horror of our own biology. The formation of Pangea Ultima is a targeted strike against the very thing that makes mammals so successful. We are endotherms, warm-blooded. We maintain a constant internal body temperature, around 37 degrees Celsius. This is an expensive way to live. It requires a lot of food, a lot of energy, but it gives us agility. It allows us to be active at night, in the cold, to inhabit almost every niche on the current Earth. Our system works because generally, the outside world is cooler than our inside world. We shed excess heat into the environment. When we get too hot, we sweat. The evaporation cools our skin. It is an elegant, efficient cooling system. But on Pangea Ultima, the system works in reverse. When the ambient air temperature is higher than your body temperature, when it is 50 degrees Celsius outside, you cannot shed heat. The heat flows into you. Thermodynamics is a harsh mistress. Heat always moves from the hotter object to the colder object. You become the heat sink. Furthermore, if you are near the coast where there might be some moisture from the poison ocean, you face the wet bulb limit. If humidity is high, sweat cannot evaporate. It It just sits on your skin, boiling you. A wet bulb temperature of 35 degrees Celsius is lethal to humans in a matter of hours, even sitting perfectly still in the shade. On Pangea Ultima, vast swathes of the continent will regularly exceed this limit. To be a mammal on door. Pangea Ultima is to be trapped in a malfunctioning spacesuit that is slowly cooking you alive. We are engineered for a temperate world, and we are heading into a furnace. The dominant life forms on this new world will not be furry, warm-blooded creatures that need to eat constantly. The heirs to the Earth will be different. They will be cold-blooded, perhaps reptilian, capable of shutting down their metabolism for months or years, waiting out the searing droughts. They will be creatures that can burrow deep underground, escaping the lethal surface sun. Or perhaps, the dominant life form will not be an animal at all. In the vast, baked interior, where the soil has turned to red dust and the winds howl at hundreds of miles an hour, creating storms that act like sandpaper blizzards lasting for weeks, life might retreat entirely to the microscopic level. Hardy bacteria hidden in rock fissures, eking out a living on mineral-chemical reactions, utterly indifferent to the hellscape above. This is the horror of scale. We look at our cities, our roads, our internet, and we feel masters of our domain. But we are living on a rented property, and the lease is expiring. The geological forces at play here are so vast, so slow, and so utterly unstoppable that human civilization is not even a rounding error in their calculations. The formation of Pangea Ultima is not a quick disaster. It is not a movie where we can build arcs or invent a machine to stop it. It is a slow, agonizing squeeze that will last for tens of millions of years. Imagine a timeline. Human civilization, from the first mud brick to the smartphone, is about 10,000 years. Pangea Ultima will exist for perhaps 50 million years, a duration of time 5,000 times longer than all of recorded human history. For 50 million years, the Earth will be a hostile, burning eye staring into the void. Any intelligence that arises during that time would look at the fossil record, at the layer of strange, processed metals and plastics we left behind, and wonder what kind of paradise must have existed to allow such soft, delicate creatures as us to thrive. They would look at our world, our blue marble, as a myth, a lost golden age that can never be reclaimed. We are currently living in the anomaly. The mild climate, the separated continents, the oxygen-rich oceans. This is the exception. Pangea Ultima is the rule. The Earth is reverting to its mean state, a state hostile to complex high-energy life. But the trap is not just thermal, it is chemical. We mentioned the volcanoes. As the continents smash together, subduction zones, where crust is shoved into the mantle, ignite volcanic arcs. The new supermountains will be studded with smoking peaks. For millions of years, these volcanoes will vent carbon dioxide into the atmosphere. Normally, the Earth has a way to handle this. Rain falls through the air, absorbing CO2, becoming slightly acidic. It lands on rocks, eroding them, binding the carbon into minerals that eventually wash into the sea and are locked away on the ocean floor for eons. This is the long-term carbon cycle. It's the planet's thermostat. But on Pangea Ultima, the thermostat is broken. Remember the super desert? No rain reaches the interior. If there is no rain, there is no weathering. If there is no weathering, the carbon is not pulled out of the atmosphere. But the volcanoes don't care. They keep pumping CO2 out. The concentration of greenhouse gases begins to spiral upward, unchecked. Levels reach 1,000 parts per million, then 2,000, then 5,000. The air becomes thick. The heat is trapped with brutal efficiency. The greenhouse effect, which once kept the planet warm enough for life, turns rabid. The Earth begins to run a fever that it cannot break. The oceans absorb heat until they can absorb no more. The surface waters get hot enough to kill coral. We are way past that. We are talking about surface waters in the tropics reaching 40 degrees Celsius, hot tub temperatures across an entire hemisphere. At this point, a terrifying feedback loop can trigger. As the water heats up, it evaporates faster. Water vapor is itself a potent greenhouse gas. More water vapor traps more heat, which causes more evaporation. This is the pathway to the anomaly we hinted at earlier. There's moist greenhouse catastrophe, the point where the Earth's climate system snaps. The stratosphere becomes saturated with water vapor. The planet's ability to radiate heat into space is compromised. If this threshold is crossed, Pangea Ultima is no longer just a difficult place to live. It becomes a sterilization event. The temperatures continue to climb until the oceans themselves begin to boil away into space. The Earth does not just end the age of mammals, it ends the age of life. It becomes a twin of Venus, a dead, pressurized, scorching rock wrapped in thick clouds of sulfuric acid. This is the high-stakes gamble the planet takes every time it assembles a supercontinent. It teeters on the edge of total oblivion, and we are on the ride. We are strapped into a roller coaster that is slowly ticking up the first great hill, and we can see the drop on the other side. The processes have begun. The Atlantic ridge is weakening, the Pacific is shrinking, the Australian plate is picking up speed. We are not separate from this process. We are part of the biomass clinging to the plates as they move into the kill zone. The ground beneath your feet is treacherous. It is not a home, it is a weapon being slowly loaded. But Pangea Ultima, for all its horror, is not permanent. Nothing on Earth is. The heat that builds up under that massive continental lid will eventually need to escape. The supercontinent will trap so much heat in the mantle beneath it that the crust will eventually dome upward, crack, and tear itself apart again. The cycle will restart. But what happens in that distant future when Pangea Ultima breaks apart? Does the world return to a paradise? Or does the cycle of destruction simply enter a new, even more terrifying phase? And what of us, the observers, looking 50 million, 100 million, 250 million years into the future? Is there any escape from the grinding gears of the geological machine? We have watched the continents collide. We have watched the oceans turn to poison and the interior of the world burn. We have witnessed the formation of Pangea Ultima, a fortress of solitude in a dying sea. But even supercontinents are mortal. They have a lifespan, and just like a star or a biological cell, they contain the seeds of their own destruction. Deep beneath the scorched surface of Pangea Ultima, the heat is building. The supercontinent acts like a thick wool blanket thrown over a radiator. The mantle below cannot shed its heat. The convection currents get trapped. The temperature rises, the rock begins to expand, it pushes upward, creating a massive blister-like dome in the center of the continent. The crust stretches, it groans, and finally, after 100 million years of unity, it cracks. Great rifts open up, not gentle valleys, but tearing wounds in the planetary skin. Lava floods out millions of cubic miles of it, paving over the deserts with fresh black basalt. Pangea Ultima is being torn apart. The cycle tries to restart. The fragments try to drift away, to form new oceans, to find a new equilibrium. But this time, the Earth is playing a game it cannot win. There is a variable we have ignored until now, a ticking clock that hangs in the sky above us, the sun. We think of the sun as a constant, a reliable friend. But the sun is a nuclear fusion reactor, and like all reactors, it changes as it burns its fuel. As the sun converts hydrogen into helium, its core becomes denser. To maintain the balance against gravity, the core burns hotter. This heat slowly leaks out. The result is that the sun gets brighter and hotter over time. In the early days of Earth, the sun was faint, 30% dimmer than it is today. That faint sun saved us. It kept the early oceans from boiling off when the atmosphere was thick with greenhouse gases. But now, the sun is entering its middle age. It is getting aggressive. By the time Pangea Ultima breaks apart, roughly 300 to 400 million years from now, the sun's luminosity will be significantly higher. The solar energy striking the Earth will be intense, and this creates a trap that geology cannot solve. The problem is carbon dioxide. It sounds counterintuitive. Today we are terrified of too much CO2. We are fighting to lower it. But in the deep future, the threat reverses. As the sun gets hotter, the chemical reactions that weather rocks, the reactions that pull CO2 out of the air speed up. Heat catalyzes chemistry. The hotter it gets, the faster the rocks absorb CO2. The Earth's natural thermostat will go into overdrive to try and cool the planet down. It will scrub the atmosphere of carbon dioxide, trying to compensate for the brightening sun. CO2 levels will plummet. They will drop below 150 parts per million, and this is where the biosphere suffocates. Plants need CO2 to live. It is their food. At 150 parts per million, photosynthesis begins to fail. The vast majority of plant life on Earth, trees, shrubs, wheat, rice, grasses, uses a pathway called C3 photosynthesis. This pathway shuts down when carbon dioxide gets too low. Imagine the forests of the post-Pangea world turning grey and brittle. Not from heat, but from starvation. The green machine that has powered life for 500 million years grinds to a halt. The base of the food chain collapses. The herbivores die. The carnivores starve. The complex web of life unravels, leaving only the hardiest grasses, the C4 plants, clinging to existence in a few isolated pockets. The earth turns brown, and then the water goes. As the sun continues to brighten, we cross the final threshold. The moist greenhouse becomes unavoidable. The atmosphere heats up to the point where water vapor can no longer be confined to the lower atmosphere. It rises into the stratosphere. There, high above the ozone layer, ultraviolet radiation from the ruthless sun smashes the water molecules apart. H2O becomes hydrogen and oxygen. The hydrogen, being the lightest element in the universe, escapes Earth's gravity. It leaks into space. It is lost forever. This is the death rattle of a habitable planet. The oceans are not just evaporating, they are bleeding into the void. The sea level drops, metre by metre. The continental shelves are exposed. The mid-ocean ridges, once teeming with life, become dry canyons. The Great Basins, the Pacific, the Atlantic, turn into salt flats that stretch for thousands of miles. The Earth becomes a desert planet, a dune-like world, but without the worms, without the spice, without the hope of rain. If you were to stand on the surface of the Earth 1 billion years from now, you would not recognize it. The sky is no longer a soft blue. It is a hazy, sickly white, choked with dust and salt crystals. The sun is a glaring, blinding eye that dominates the heavens. It looks too big. It feels too close. The temperature is 100 degrees Celsius during the day. Water boils in the shade. The only life remaining is single-celled organisms hiding deep in the crust, hiding in the last pockets of subterranean brine. We are back to where we started. The Earth began with microbes, and it will end with microbes. The age of animals, the age of dinosaurs, the age of humans. It was just a brief, chaotic, beautiful fever dream in the middle of a long, dull silence. And what of us? What of the builders? The dreamers? If humanity is still here when Pangea Ultima forms, we will have changed. We will have been forced to evolve or engineer ourselves into something unrecognizable. Perhaps we will have burrowed underground, building vast subterranean cities powered by the dying heat of the core. Perhaps we will have uploaded our minds into silica, becoming creatures of data and electricity immune to the heat. But the most likely scenario, the one that the laws of physics push us toward, is exile. The Earth is not a permanent home. It is a womb, and a womb eventually becomes a tomb if you do not leave it. The formation of Pangea Ultima is the eviction notice. It is the universe telling us that we have overstayed our welcome. The timeline is vast, but the conclusion is binary. We either leave this rock or we die with it. There is no middle ground. We look at Mars. We look at the moons of Jupiter, Europa, Enceladus, cold, icy worlds. Today they are frozen wastelands. But as the sun brightens, as Earth burns, those icy moons will melt. They will become ocean worlds. The habitable zone of the solar system will shift outward. Perhaps our descendants will stand on the shores of a melted Europa, watching the giant Jupiter hang in the sky, and they will tell stories of the old world, the blue world, the world that was consumed by fire. They will look through their telescopes at the third rock from the sun, and they will see a Venus-like hellscape, a planet shrouded in thick reflective clouds, glowing with thermal radiation. They will point to it and say, "That is where we began, that is the cradle, and that is the grave." But even that is a temporary reprieve. The sun will eventually swell into a red giant. It will swallow Mercury, it will swallow Venus, it will expand until its fiery atmosphere licks the surface of the Earth. The drag will pull our planet into the stellar furnace. The Earth will be vaporized. The very atoms that make up your body right now, the calcium in your bones, the iron in your blood, will be returned to the star that forged them. The slate will be wiped clean. This is the ultimate context of our existence. We are a momentary flash of consciousness on a rock that is drifting toward a furnace. It sounds bleak. It sounds terrifying. And in a way, it is. It creates a sense of cosmic vertigo. The realization that the ground beneath us is not safe, and the sky above is not empty, but filled with a countdown. But there is another way to look at it, a way that transforms the horror into a strange, cold beauty. The universe owes us nothing. It does not owe us stability. It does not owe us survival. The fact that we are here, right now, in this brief, lush window of the Earth's history, is a statistical miracle. We are living in the golden age. The continents are spread out. The climate is temperate. The oceans are oxygenated. We can breathe. We can look up. We can understand. We are the eyes of the universe. We are the mechanism by which the cosmos knows itself. The formation of Pangea Ultima is a reminder that we are not the masters of this planet. We are its guests. And like all guests, we must eventually pack our bags. The story of Earth does not end with a happily ever after. It ends with silence. It ends with rock and fire. But the story of us, that is still being written. The threat of Pangea Ultima is a challenge. It is the pressure that creates the diamond. It forces us to look upward, to look outward, to realize that our destiny is not to cling to the soil of a single world, but to drift among the stars. The continents are moving. You can't feel it, but they are. Every second the Atlantic widens. Every second the Pacific shrinks. The clock is ticking. The machine is running. Tonight, when you lie in bed, in the quiet of your room, listen. Listen past the traffic, past the wind in the trees. Listen to the deep, resonant silence of the ground beneath you. It is not sleeping. It is waiting. It is preparing. The earth is a traveller, and it is moving on. The only question that remains is, will we be moving with it, or will we be left behind in the dust of the final supercontinent? The choice is not ours to make today, but the preparation begins now. Look at the map. Memorize the coastlines, cherish the blue, because in the deep time of the cosmos, it is already gone.